In this lesson, I'm going to show you how to graph a parabola when the equation is in standard form. We will look at how to find each of the four key features when the equation is in the form y equals ax squared plus bx plus c. The first feature of the equation y equals negative x squared minus 2x plus 3 that we're going to find is the axis of symmetry. The axis of symmetry is a vertical line that will go through the vertex in the middle of the parabola. Since it's a vertical line, the equation is x equals some value h, and h is negative b over 2a. If you have trouble remembering this, think of the quadratic formula without the square root part in the numerator. To find h, we need to substitute in a negative 1 for a in the denominator and a negative 2 in for b in the numerator. This simplifies to a positive 2 over negative 2, which reduces to negative 1. So since h equals negative 1, x equals negative 1 is the equation of our axis of symmetry. All we need to do now is sketch the line before moving on to the vertex. X equals negative 1 is the vertical line where every point has an x coordinate equal to negative 1. So you could plot the point negative 1, 0 on the x-axis and just draw the vertical line through it. Next, we need to identify the vertex of the parabola. To do this, we can use h and k to represent the coordinates. We already know what h is from finding the axis of symmetry. So we know the vertex is the point negative 1 something. To find k, the y-coordinate, we can just substitute negative 1 in for x and solve the equation k equals a negative 1 squared minus 2 times negative 1 plus 3. Be careful when simplifying this. Negative 1 squared equals negative 1 because negative 1 squared is positive 1 and then that is made negative. Also, negative 2 times negative 1 is plus 2. So now we have k equal to negative 1 plus 2 plus 3 equals 4. That means that our vertex is the point negative 1, 4, and we can plot that on the graph. The only question now is whether the vertex is a max point or a min point. For this, we'll look at a, the coefficient of x squared. Since a is negative, the parabola will open down, so the vertex is a max point. This is easy to remember because if you have negative feelings, you frown, and that's what the parabola with a negative a looks like, a frown. The next feature we need to find is the y-intercept. The y-intercept is on the y-axis, which means it is a point with 0 as the x-coordinate. So we need to substitute 0 in for x in the equation. Now we have the equation y equals a negative 0 squared minus 2 times 0 plus 3. As we simplify this to solve for y, the first two terms both equal 0. So we have 0 plus 0 plus 3, which is 3. This gives us the point 0, 3 as the y-intercept. So we plot that point on the graph. Notice that for this form, the y-intercept will always end up equal to c. So you can just look at the equation and write the value down. Finally, we need to find the x-intercepts. The x-intercepts are points on the x-axis, so the y-coordinates equal 0. To find the x-intercepts, or zeros, we substitute 0 in for y and solve for x. The equation we get, 0 equals negative x squared minus 2x plus 3 is a quadratic equation, and we could solve it by factoring or by the quadratic formula. This one is pretty easy to factor, so we'll do it that way this time. First, we need to get rid of the negative 1 in front of the x squared, so we can divide both sides of the equation by negative 1, which will change the signs of every term to give us 0 equals a positive x squared plus 2x minus 3. Now we have a trinomial that will factor into x plus 3 times x minus 1. And we can use the zero product property to find the roots. X equals negative 3 or positive 1. Now we know the two x-intercepts are negative 3, 0 and 1, 0. We'll plot these on the graph and label them with z's because they show us the zeros. Notice that the x-intercepts are both two spaces away from the point where the axis of symmetry crosses the x-axis. That's because the parabola has symmetry. If the x-intercepts you find are not evenly spaced on either side of the axis, then you know you did something wrong. Finally, all we have to do is connect the points we have with the curve. And we're finished with the parabola. Now that you've learned how to graph parabolas in either vertex or standard form, try some of the activities to practice finding these features and graphing them on your own.